What if intelligence on Earth did not begin with us, nor with the dinosaurs, nor even with the first animals that walked or swam, but with civilizations so ancient that time itself has erased every trace of their existence? What if the world we inhabit is not the first chapter of Earth's story, but merely the latest page in a book written and rewritten by cycles of creation, destruction, and rebirth? When we look at fossils, we imagine origins. When we look at comets, we imagine omens. Yet both may be fragments of messages left by forgotten epochs that predate anything the human mind has been taught to consider possible. Today, scientists observe a new anomaly. Comet R2 SWAN has triggered a striking sunward tail, bending its luminous arc toward the sun in a formation that mirrors the impossible behavior once recorded in 3I Atlas. Two different bodies, two different origins, one repeated cosmic pattern, and both now hover within Earth's outer shell, as if retracing an ancient pathway encoded into the rhythms of the solar system. To astronomy, this is a curiosity. To physics, a challenge. But to those willing to look deeper, the synchronized behavior of these comets raises a question far older than science itself. How many times has intelligent life risen, flourished, and vanished, leaving behind only subtle patterns for the next civilization to decode? Earth's crust records catastrophic resets, floods of lava, oceans freezing solid, continents torn apart, and atmospheres shifting in violent breaths. Each reset wipes the surface nearly clean. Each reset buries eras of complexity beneath stone and silence. If advanced civilizations existed before the dinosaurs, their memories would survive not as ruins or artifacts, but as geological anomalies, unexplained evolutionary leaps, and echoes embedded in the subconscious architecture of life. And if the cosmos influenced their rise or collapse, then the synchronized alignment of R2 SWAN and 3I Atlas may be part of a cycle that they once understood, and that we are only now beginning to notice. This is the journey we enter, a descent into Earth's deep time, where the line between science and myth begins to blur, where the fossil record speaks in whispers, and where forgotten civilizations might still resonate through patterns written in stone, sky, and consciousness itself. If you feel drawn to mysteries older than history, share your thoughts in the comments and subscribe so you can join us on each step of this unfolding journey into Earth's forgotten past. R2 SWAN should not be doing what it is doing. Comets, by all standard physics, form tails that flow away from the sun, shaped by radiation pressure and solar wind. Yet R2 SWAN has done something profoundly unusual. It has extended a sunward tail, an inward-turning stream of charged particles bending against the force that rules the solar system. This is not an ordinary event. Only a few comets in recorded observation have demonstrated such behavior, and even fewer with the striking symmetry seen now. The last notable case was 3I Atlas, an interstellar wanderer whose own sunward stream challenged every conventional model. For two unrelated bodies to replicate the same anomaly in the same era while drifting through Earth's outer gravitational shell is statistically improbable to the point of impossibility. If space is a stage of randomness, this should not happen. If the cosmos is a system of cycles, then we may be witnessing the reappearance of a pattern older than our species. R2 SWAN's tail is not simply a stream of ionized gas. It is a response to forces we have not fully grasped, perhaps influenced by electric fields, magnetic structures, or gravitational harmonics seldom observed in tandem. And yet the comet behaves as if following a script. It mirrors 3I Atlas in its curvature, luminosity variation, and trajectory shift. Both hover in Earth's extended gravitational influence, the outer shell that delicately steers small bodies through subtle resonances. These comets appear as though aligning to a corridor, a boundary, a route carved not by celestial mechanics alone, but by something rhythmic, something that echoes across epochs. When patterns repeat in nature, we look for causes. When patterns repeat across cosmic distance, we look for meaning. R2 SWAN and 3I Atlas create a resonance not only among astronomers, but among all who sense that the sky may hold stories older than humanity. Civilizations rise and fall on Earth, but the cosmos remains the one place where cycles cannot be hidden. When planets shift, when comets return, when the sun pulses, the universe quietly reveals a timeline far deeper than human history. Patterns in the heavens have long been interpreted as messages, warnings, or omens, yet in truth, they may be natural records, signals of events that shaped Earth before the first dinosaur shook the ground. Earth's gravitational corridor, the region where both comets now hover, is not a static place. It is a fluctuating shell influenced by solar cycles, lunar resonance, and the hidden tug of mass beneath the crust. Bodies drifting through this corridor often behave unpredictably, but never in mirrored formation like this. Their synchronized anomaly forces us to question whether the laws we use to understand the solar system are incomplete, or whether this corridor is a kind of gateway, a place where cosmic cycles become visible, where celestial behavior interacts with planetary rhythms in ways we have yet to understand. Imagine this corridor as a boundary between Earth's story and the universe beyond. Everything crossing it leaves an imprint: electromagnetic traces, gravitational ripples, subtle shifts in atmospheric chemistry. Ancient civilizations, if they existed long before the dinosaurs, may have been shaped by these same cosmic patterns. They might have seen comets such as these not with fear or awe, but with recognition, understanding them as markers of environmental change. Perhaps they sensed that each celestial cycle carried the potential to reshape ecosystems, ignite evolutionary jumps, or trigger extinctions. If intelligence existed in those prehistoric epochs, its relationship with the sky would not be superstition, but survival. Today, as we observe R2 SWAN and 3I Atlas echo one another's impossible behavior, we are reminded that cosmic events often synchronize with major transitions on Earth. Past mass extinctions align with orbital shifts. Evolutionary explosions match periods of intense cosmic radiation. Geological resets coincide with comet showers and shifts in solar activity. The universe leaves fingerprints across Earth's deep time, but we rarely recognize the patterns because our timeline is too short. Humanity has existed for a blink, dinosaurs for only a page, but life itself stretches across volumes we have yet to read. Comets like R2 SWAN may be footnotes in that ancient story, signals returning on cycles longer than our species' memory. If the comet's synchronized behavior is part of a larger cosmic rhythm, then this moment is not isolated. It may be one beat in a repeating pattern that shaped Earth's earliest civilizations, not human civilizations, but unknown forms of intelligence that evolved in prehistoric worlds erased by geological violence. They may have interpreted these cosmic phenomena not as anomalies, but as recurring cues. They may have understood that the alignment of bodies across the solar system marks transitions in climate, magnetism, and the stability of ecosystems. If their knowledge dissolved into the Earth long before bones could fossilize, what remains might be found only in the patterns themselves, patterns now repeating with R2 SWAN and 3I Atlas. We must then ask whether this alignment reflects a shift already beginning on Earth. Subtle magnetic variations, unexplained temperature pulses, atmospheric anomalies mirroring ancient cycles found in geological layers. These cycles may hold the key to understanding why civilizations might have risen before the dinosaurs, how they vanished, and why these cosmic triggers reappear at specific moments. And as we examine the celestial behavior unfolding above us now, it becomes essential to descend into Earth's deep past, to uncover the truth hidden beneath millions of millennia of stone, to read the signatures left behind by civilizations unlike anything we can currently imagine, bringing us to the question of why Earth destroys its own history with such fierce consistency, and why that destruction may hold the first clue to unraveling. To imagine civilizations before the dinosaurs is to confront the deepest bias in human thought, the belief that intelligence is recent, fragile, and uniquely tied to the forms familiar to us. We picture civilization as stone tools, spoken language, metallurgy, cities, agriculture. But these are merely human expressions of intelligence, not the definition of intelligence itself. When we extend our gaze into Earth's pre-dinosaur epochs, hundreds of millions of years further back, we enter a world where life did not resemble anything we recognize today. And in those alien landscapes, intelligence might have emerged in shapes, scales, and systems so different that our minds struggle to conceive them. The fossil record provides only a whisper of this ancient world. Its timeline is fragmented, devoured by erosion, tectonics, volcanic resurfacing, and biological decay. 99% of all life leaves no fossil at all, and the deeper we travel into geological strata, the more the record dissolves into silence. What is preserved from the time before dinosaurs are mostly shadows, trace fossils, chemical signatures, environmental anomalies. Yet within these shadows are clues that something more complex may have existed. Patterns of behavior fossilized in sediment, not because the organisms had bones, but because they moved with purpose, leaving behind tracks that resemble coordination, communication, or even design. When we speak of prehistoric civilizations, we must abandon the expectation of architecture and technology. Instead, consider civilizations that evolved from distributed intelligence, oceanic collectives, reef-based superorganisms, fungal networks spanning entire continents, chemical communication systems more advanced than language, intelligence that did not require hands, tools, or fire, intelligence that shaped ecosystems the way humans shape environments today, not through construction, but through bioengineering. To imagine such civilizations, one must look beyond human parallels and dive into the logic of life itself. The earliest complex organisms were experiments in form and function, and intelligence may have emerged as a natural extension of survival, coordination, or environmental mastery. Many scientists argue that intelligence requires a nervous system, a brain, and a stable environment. But this assumption collapses when we examine the Cambrian explosion, where complexity erupted with astonishing speed. Predator-prey dynamics accelerated. Eyes evolved with optical precision rivaling modern engineering. Creatures navigated environments with advanced sensory perception long before vertebrates dominated. Intelligence could have taken root in any of these lineages, not as human-like cognition, but as collective problem-solving, coordinated movement, or adaptive environmental response. Civilization, in this context, becomes less about creation and more about influence. A civilization may have shaped ocean chemistry, redirected nutrients, or engineered symbiotic relationships across entire regions of the planet. In the Ediacaran period, we find organisms that defy every classification. Soft-bodied, fractal-patterned, sprawling across the seafloor like living networks. They show signs of growth patterns that seem too ordered to be random, too organized to be primitive. Some researchers believe these organisms may represent a lost branch of life, unrelated to anything alive today. If they possessed intelligence, it would not look like anything recognized by modern biology. Their bodies could have acted as processors. Their internal fractal divisions could have been communication pathways. Their environmental impact could have been their version of technological advancement. But why would such civilizations leave no visible traces? Because Earth is designed to erase. Continental drift destroys land. Subduction swallows crust. Oceans dissolve organic material. Ice ages grind continents into dust. Volcanic events smother ecosystems. Asteroid impacts wipe entire branches of life in seconds. Every 100 million years, Earth resets itself. What survives these resets are not structures, but patterns, chemical fingerprints, environmental disruptions, fossilized behaviors, sudden evolutionary leaps. These are the shadows of possibility. Shadows that suggest intelligence may have risen long before the dinosaurs, only to be erased by time, resurfacing again in different forms across Earth's cycles. Imagine a civilization that expanded not outward but downward, embedding itself in sediments or oceanic crust. A civilization that communicated via bioluminescent pulses across deep-sea networks. A civilization whose technology was biological, not mechanical. A civilization whose collapse left behind no ruins, only subtle imprints in carbon layers or isotopic anomalies that modern geology struggles to interpret. These possibilities challenge the assumption that intelligence must be human-like to be real. They require us to acknowledge that Earth's earliest civilizations, if they existed, might have been unrecognizable to us even if we stood beside them. The greatest barrier to imagining prehistoric civilizations is the human demand for tangible evidence. Yet the absence of ruins is not the absence of history. It is the consequence of a planet constantly healing, shifting, consuming. The deeper we go in time, the fewer artifacts survive. Even the dinosaurs' world, much more recent, is patchy and incomplete. Go back another 300 million years, and the record becomes a thin veil. And behind that veil lie entire eras of complexity we may never fully recover. Still, patterns remain. Evolutionary jumps that happen too fast. Extinction events too synchronized. Geochemical anomalies without natural explanation. Fossilized behaviors that imply collective intelligence. These fragments draw us toward a hypothesis that defies our training, but not our logic. Intelligence may have arisen multiple times, each cycle ending with a reset, each reset leaving behind faint traces, each trace waiting for another intelligent mind to notice. And now, as we confront the synchronized anomalies of R2 SWAN and 3I Atlas, we begin to wonder whether ancient civilizations once recognized such cosmic patterns as part of a cycle that shaped their existence. Whether they watched comets the way we watch the seasons. Whether they understood the sky not as chaos, but as a clock marking the rise and fall of worlds. And to explore that possibility, we must now examine how Earth itself destroys its own history with ruthless precision, revealing why so little survives from the ages before the dinosaurs, and why that destruction may be the key to understanding Earth is not a museum. It is not a vault. It is not a planet designed to preserve its memories. It is a restless, shifting, molten engine that consumes its own history with the same inevitability that fire consumes paper. Every continent, every ocean, every mountain range we see today is nothing more than the latest draft of a planet that has rewritten itself countless times. To understand why civilizations before the dinosaurs would leave almost nothing behind, we must first confront a truth rarely acknowledged. Earth suffers from deliberate geological amnesia. Continents drift like rafts across a glowing sea of magma. They collide, fracture, sink, rise, and vanish in cycles lasting hundreds of millions of years. A city built 400 million years ago would not be buried beneath soil. It would be swallowed by the mantle, melted, recycled, and eventually re-emerge as volcanic rock on the other side of the planet. Across such timescales, even mountains dissolve. Oceans appear and disappear. Entire biomes vanish without a single fossil left behind. The more ancient the civilization, the less chance any trace survives us. Subduction zones, the places where crust sinks back into Earth, are executioners of deep time. Anything settled on plates drifting toward these zones is dragged downward and destroyed. Even massive geological structures are erased. If Earth built skyscrapers of stone, those skyscrapers would crumble, churn, melt, and reform into new rock thousands of kilometers away. Civilizations older than dinosaurs would stand no chance against such relentless recycling. And it is not only tectonics that erase. Erosion wears down continents grain by grain. Water slowly dissolves landscapes. Wind sculpts and destroys. Ice grinds mountains into dust. Over tens of millions of years, no structure can survive unaided. Fossils remain only when conditions are perfect: quick burial, mineralization, stability. Without these rare circumstances, life leaves no physical trace. 99% of species that ever lived vanished without fossil evidence. If Earth can erase entire ecosystems, it can erase civilizations just as easily. Volcanism is another mechanism of forgetting. Supervolcanoes erupt with force capable of covering continents with ash, burying ecosystems in instant geological darkness. Lava fields spread for thousands of kilometers, layering over ancient surfaces, sealing them beneath kilometers of basalt. A civilization caught beneath such flows would be flattened, incinerated, swallowed. Even human ruins buried beneath volcanic ash require only thousands of years to erode into fragments. Now extend that to millions of years, tens of millions, hundreds of millions, and the result is not ruin, but total disappearance. But Earth's amnesia is not only physical, it is chemical. Over deep time, carbon cycles shift unpredictably. Atmospheric composition swings from oxygen-rich to oxygen-poor. Oceans fluctuate between acidic and alkaline. Biological signatures dissolve or transform. Chemical traces of ancient civilizations, if they existed, would be distorted beyond recognition, integrated into new organisms, or bonded into new minerals. Prehistoric technology, if biological, environmental, or chemical, would merge into the natural world. What remains today, would not be a tool or artifact, but a clue mistaken for natural anomaly. The oceans, too, bury and erase. Seafloor sediment accumulates quickly, covering entire regions, compressing organic material into layers that later become rock. But the oceans are temporary archives. Once a seafloor slab approaches a trench, everything upon it is destroyed. Even coral reefs, which today seem eternal, have lived and died in cycles long before the dinosaurs appeared. If an oceanic civilization existed hundreds of millions of years ago, it might have left behind patterns of reef formation, chemical gradients, or strange fluctuations in carbon deposits. But artifacts, structures, or recognizable remnants? Those would be lost to the churning of the deep. This raises an important realization. Evidence of pre-dinosaur civilizations would not take the form of cities or ruins. Instead, it would emerge as irregularities, geological signatures that should not exist, fossil behaviors that defy explanation, mineral concentrations laid out with improbable symmetry. These fragments may hint at manipulation, influence, or design, but they would be indistinguishable from natural patterns unless seen as part of a larger puzzle. Earth hides its past not through malice, but through constant transformation. And yet some traces endure, not in rock or artifact, but in inconsistencies, anomalies, and questions science cannot yet answer. Our planet's violent memory loss forces us to rethink the nature of ancient civilizations. They may not have built in stone. They may not have constructed anything that would withstand a volcanic purge or a continental shift. Their influence might have been ecological rather than architectural. They may have shaped the distribution of early life, sculpted chemical environments, or created ecosystems organized with intelligence rather than structures built with hands. Their footprints would be geological, biological, or atmospheric, not architectural. And when we look at Earth with this understanding, the record begins to shift. Sudden oxygen spikes, abrupt evolutionary leaps, layers where sediments change too quickly, magnetic anomalies, strata showing synchronized global events without clear cause. The deeper we go, the more these clues accumulate. They suggest influence, intervention, or patterns too coordinated to be mistaken for random chance. These markers may be the real evidence of civilizations predating the dinosaurs, civilizations erased by Earth's relentless cycles of destruction. To follow these clues, we must now turn to the anomalies themselves. The scattered, enigmatic signatures found in ancient rock, the mineral compositions that violate natural expectations, the behavioral fossils that mimic structure and intent. These fragments may form the first faint map of civilizations lost to deep time, guiding us toward the hidden evidence Earth failed to fully erase and leading us to question why these anomalies appear in the exact periods associated with when a civilization vanishes in deep time. It does not leave ruins. It leaves distortions. It leaves patterns. It leaves signatures that nature struggles to replicate. These traces are subtle, fragile, often indistinguishable at first glance from ordinary geological processes. Yet when examined closely, when placed within the context of Earth's cycles and what we now understand about deep time erasure, certain anomalies refuse to blend into the background. They stand out like quiet confessions, as if the planet inadvertently preserved a few pieces of a story it worked so hard to erase. Begin with heat signatures locked into ancient rock. In several prehistoric layers, geologists find abrupt spikes of thermal alteration concentrated in strange, sharply defined regions. These are not the smooth gradients created by volcanic activity or meteor impacts. They form geometric boundaries, sharply delineated thermal zones that cool too quickly and too evenly to be natural. Picture a heat field that rises and falls with deliberate precision, a thermal footprint that seems more engineered than geological. Something heated these sediments in a way that nature rarely achieves on its own. And when this happens on a scale spanning thousands of square kilometers, we must ask whether this heat was environmental, biological, or directed by an intelligence unfamiliar to us. Now consider the mineral irregularities, deposits of elements arranged with a symmetry difficult to explain. In regions dated hundreds of millions of years before dinosaurs, geologists uncover bands of minerals aligned with mathematical precision, as though laid down according to some guiding structure. These formations defy the chaotic layering expected from natural sedimentation. They look almost curated. Some layers contain rare earth element clusters concentrated far beyond natural distribution models. These clusters do not suggest mining or construction in the human sense, but they hint at processes, biological or environmental, that organized minerals in ways that appear too intentional to be random. In the same strata, we discover chemical signatures that rise and fall in rhythmic cycles. Patterns in carbon, sulfur, and oxygen isotopes shift too abruptly, too coherently, suggesting global environmental manipulation. These chemical waves resemble the fingerprints of systems attempting to regulate planetary conditions, systems that respond to stress, balance atmospheric composition, or correct ocean chemistry. Nature is capable of cycles, yes, but nature rarely produces global rhythms with such sudden onset and organized recovery unless pushed by influences outside pure geology. Then come the trace fossils, fossilized behaviors rather than bodies. These are among the most haunting forms of silent evidence. Patterns preserved in sediment reveal organisms moving in coordinated formations millions of years before brains evolved. Tracks branch and reconnect like neural networks. Burrows form perfect grids, circles, spirals, patterns that look algorithmic. In some places, the entire seabed appears to have been etched by creatures acting with purpose, mapping, measuring, and possibly altering their environment. A single organism cannot achieve this. A collective could. A civilization, in a form we do not recognize, might have shaped these networks the way humans shape landscapes. Even more unsettling are the anomalies found in deep oceanic crust. Magnetized patterns appear across ancient basalt layers, forming vast stripes that align with neither Earth's natural magnetic reversals nor plate dynamics. These magnetic imprints suggest large-scale processes capable of altering crustal magnetization in deliberate patterns. Could a prehistoric intelligence, chemical, electrical, or biological, have influenced magnetic fields across regions of the seafloor? If so, the result would be precisely what we observe. Magnetic signatures too structured to be volcanic, too patterned to be accidental, too ancient to align with any known species. Another category of silent evidence lies in the sudden environmental stabilizations occurring in prehistoric eras. After periods of catastrophic change, oxygen spikes, glaciations, or mass die-offs, the planet sometimes recovers unnaturally quickly. Climate steadies, ocean chemistry resets, biodiversity rebounds within a time frame too short for natural processes. Something seems to assist the recovery, something adjusts the balance. These events hint at the presence of systems, organic or intelligent, that regulated environmental collapse, restoring equilibrium with a speed suggesting coordination. If a civilization existed before the dinosaurs, it may have devoted its intelligence not to construction, but to planetary management, leaving signatures in the environmental record rather than in architecture. Still more clues emerge in the form of synchronized anomalies across continents separated by oceans. Identical chemical patterns appear in strata thousands of kilometers apart. Mineral disruptions occur simultaneously across ancient landmasses. Evolutionary bursts happen in distant ecosystems within the same narrow time frame. This global coherence is rare in nature, but common in systems guided by intelligence. A civilization operating at the scale of an ecosystem, or a biosphere, might influence regions worldwide, leaving behind fingerprints we see today as coincidental geologic parallels. And then there are the peculiar absences, layers where expected fossils do not appear, where sediment deposition halts abruptly, where ecosystems vanish without the usual signs of extinction. These voids may indicate catastrophic events that left no conventional trace, or they may reflect transitions orchestrated by ancient systems we have yet to understand. In a world with intelligent life unlike our own, distributed, oceanic, fungal, or chemically networked, the collapse of a civilization would leave no ruins, but would change the planet in ways detectable only through anomalies like these. All these clues, these silent signatures, converge into a possibility that challenges everything we believe about Earth's past, not ruins, not artifacts, but patterns, geological sequences that vibrate with intention, chemical cycles that seem regulated, behaviors fossilized in sediment that appear algorithmic, global synchronizations that hint at planetary scale influence. These traces do not prove a prehistoric civilization existed before the dinosaurs, but they raise questions that cannot be ignored. And to understand how life could produce such anomalies long before vertebrates dominated the planet, we must now turn from the rocks to the organisms themselves, from geological signatures to biological revelations that challenge the very notion of evolution's timeline and guide us toward the sudden, staggering evolutionary detonations that suggest intelligence may have shaped. When we turn from stone to life, from geological signatures to biological emergence, the mystery deepens. Evolution is often described as gradual, incremental, shaped by environmental pressures over immense spans of time. Yet Earth's history contains moments that defy this rhythm. Moments when life does not progress gently, but erupts. When new forms appear with startling complexity, as though the planet itself exhaled an entirely new blueprint. These evolutionary detonations raise questions that traditional models struggle to answer, and they lie at the heart of the possibility that prehistoric civilizations, non-human, non-technological in the human sense, may have influenced or even engineered aspects of early life long before the dinosaurs ever appeared. The most famous of these detonations is the Cambrian explosion. In an astonishingly brief geological moment, nearly every major animal group appears in the fossil record. Complex eyes, intricate limbs, advanced digestive systems, hard shells, segmented bodies. Prior to this, for billions of years, life remained simple, soft-bodied forms drifting through ancient seas. Then, as if triggered, complexity bloomed. The suddenness of this shift is so dramatic that paleontologists still debate its cause. Environmental change alone cannot explain it. A surge in oxygen levels helps, but does not account for the precision of the evolutionary architecture. It is as though life experienced a collective awakening. Trilobites emerge in this era with eyes so advanced they rival the optical sophistication of modern creatures. Their lenses are made of calcite, arranged with geometrical precision. Some species possess eyes capable of focusing multiple depths simultaneously, a feature unknown in most animals today. These are not primitive experiments. They are perfected designs. They appear fully formed without transitional fossils showing gradual development. How does nature produce such complexity so quickly? Either evolution occurs in ways we do not yet understand, or forces beyond slow accumulation shaped these systems. Elsewhere in the Cambrian strata, we find organisms with defensive spines arranged in mathematical patterns, digestive tracts more efficient than those of later species, and sensory organs implying advanced environmental interaction. These creatures arrived in coordinated bursts, representing not slow adaptation, but a coherent shift in biological innovation. It resembles not trial and error, but execution of a larger, synchronized update. This pattern is not unique to the Cambrian. Earlier, in the Ediacaran period, soft-bodied organisms appear with fractal designs that suggest environmental responsiveness far beyond their morphology. They grow in repeating patterns, organize themselves in colonies, and adapt to shifting conditions with a fluidity unmatched by later life. Some scientists propose that these organisms communicated chemically across large distances, forming networks more sophisticated than the roots of modern forests. If intelligence existed then, it would not manifest as consciousness in the human sense, but as coordinated behavior, environmental engineering, and adaptive complexity. It would resemble a civilization without tools, a civilization woven into biology itself. Even earlier still, microbial mats demonstrate organization that hints at collective intelligence. They build layered structures, respond to light variations, adjust chemical gradients, and modify their environment for survival. These mats create geological formations known as stromatolites, which appear in rhythmic, intentional-looking shapes. Are these merely survival strategies evolved by simple organisms, or could they represent early forms of ecological engineering, primitive yet deliberate systems influencing their surroundings? Over time, such systems could have grown into something more. Networks of cooperative intelligence spanning entire coastlines or oceanic shelves. The idea that prehistoric life may have been guided by intelligence, not necessarily conscious but functional, is controversial, yet the fossil record forces us to engage with anomalies, sudden bursts of genetic diversification, rapid increases in organism size, simultaneous appearance of traits across unrelated lineages. These detonations suggest either major external influences, environmental catalysts, or a hidden dimension of evolutionary dynamics we have yet to uncover. Consider the possibility that ancient civilizations did not build machines but shaped settings, that they did not write language but encoded information in ecosystems, that their impact is visible not as artifacts but as patterns within life itself. An environmental intelligence, distributed, decentralized, emergent, could influence evolution subtly, leaving no ruins, only rhythm, only complexity appearing in coordinated pulses. Modern analogs support this idea. Slime molds solve mazes without brains. Ants and bees build cities without centralized leadership. Fungal networks transmit resources and signals across forests. Coral reefs behave like cooperative superorganisms. Intelligence in nature often emerges from simple parts forming a larger whole. If such systems were more advanced in Earth's deep past, their influence on evolution could have been profound. Their collapse, whether caused by environmental catastrophe, cosmic shifts, or geological resets, would not leave skeletons or tools but gaps in the fossil record, abrupt extinctions, and strange bursts of complexity following the void. Evolutionary detonations, then, may represent not sudden natural change, but remnants of cycles, civilizations rising, shaping life, collapsing, and allowing new forms to emerge from the disruption. Each detonation could be both an ending and a beginning, a transition orchestrated by forces we do not yet understand. And as we explore these possibilities, as we consider that the very structure of life may contain echoes of ancient intelligence, this is a perfect moment to pause and ask something important from you. If this investigation is awakening questions, if it is pulling you deeper into the mystery of Earth's forgotten past, take a moment to like this video and subscribe. Your support ensures that this exploration continues, and that these hidden chapters of Earth's history can be uncovered one layer at a time. To understand the true scale of prehistoric civilizations, however, we must now look at the violent interruptions that repeatedly reset life on Earth. Resets so complete, so devastating, that they would erase not only species but entire civilizational patterns, drawing us into the cataclysms that wiped clean the stages on which ancient intelligence may have once to understand why no clear trace of prehistoric civilization survives. We must confront the reality that Earth is not only capable of supporting life, but just as capable of erasing it. Across the planet's vast timeline, entire worlds have risen and collapsed in cycles of unimaginable violence. These cycles are not isolated disasters. They are orchestrated resets, planetary fractures where life is forced to begin again, often from a fraction of its former complexity. If civilizations existed before the dinosaurs, these catastrophes would have annihilated them completely, leaving behind only the faintest whispers in rock, chemistry, and evolutionary echoes. Among the most devastating of these events is Snowball Earth. Not once, but likely multiple times, the planet froze from pole to equator in sheets of ice kilometers thick. Oceans crystallized at the surface. Sunlight vanished beneath frozen shells. Photosynthesis collapsed. Entire ecosystems suffocated under a planetary shroud. In such conditions, anything resembling a civilization, whether biological, ecological, or networked, would be extinguished. For millions of years, Earth remained locked in this frozen state, grinding away at its history like a glacier erasing a footprint. If intelligence flourished before such freezes, the ice would have obliterated it completely. Then we face the violent opposite, mantle overturns. These are among Earth's most catastrophic internal resets. Superheated material from deep within the mantle rises swiftly to the surface, unleashing global volcanism on a scale that reshapes continents. Lava floods thousands of kilometers. Toxic gases smother the atmosphere. Temperatures swing from scorching to suffocating. During such upheavals, not only would surface civilizations be destroyed, but the crust itself would be rewritten. Any structure, any ecological system, any trace of intelligence, erased by molten rock and suffocation. But even mantle overturns pale beside the greatest volcanic events known as large igneous provinces. These eruptions do not last days or years. They can continue for hundreds of thousands of years. They release carbon dioxide, methane, sulfur, and aerosols in quantities capable of collapsing global climate systems. Oceans turn acidic. Oxygen levels plummet. Food chains break in catastrophic cascades. More than once, these volcanic provinces have triggered mass extinctions. A civilization, even a resilient one, could not survive a world where air becomes poison and ecosystems collapse in synchronized waves. Astrophysical resets add another layer of destruction. Gamma-ray bursts, supernovae, and cosmic radiation pulses can strip away atmospheric ozone, bombard the surface with lethal radiation, and alter genetic structures globally. Life may survive in deep oceans or underground refuges, but surface civilizations, especially those built on biological networks or chemical communication, would be eradicated. Their remains would dissolve into geological cycles, leaving behind only isotopic anomalies indicating a sudden spike in cosmic exposure. There are also the great oxygenation events, times when atmospheric composition shifted so dramatically that entire worlds suffocated. The first major oxygen increase extinguished countless anaerobic organisms, reshaping biology forever. Later swings in oxygen levels caused instability so profound that entire ecosystems collapsed. Civilizations relying on stable atmospheric chemistry, especially those built on delicate biochemical systems, would not withstand these abrupt changes. Oceanic anoxic events add yet another layer of planetary forgetting. At several points in Earth's history, oceans lost their oxygen entirely, turning into vast toxic basins where microbial life dominated and larger organisms suffocated. These events lasted long enough to erase entire marine ecosystems, burying organic matter in thick sediment layers that would eventually transform into black shale. If oceanic civilizations existed, distributed networks, advanced reef systems, or collective organisms, they would have drowned in chemical darkness, their remains compressed into stone. Meteoric bombardment marks the final category of deep time resets. While the dinosaur-killing impact is the most famous, it is not the only one. Earlier impacts were even more devastating. Some vaporized oceans, some ignited global firestorms, some blasted continents apart. An asteroid strike is an efficient eraser. It destroys surface life instantly, reshapes climate, and plunges the world into years of darkness. Civilizations caught in such events would vanish in an instant, their memory preserved only as a thin line of iridium or shocked quartz. What makes these resets even more formidable is their synchronicity. Many occur not once but repeatedly, aligned with cosmic cycles, orbital fluctuations, or internal instabilities. It is as though Earth periodically sweeps its slate clean, preparing for new iterations of life. If intelligence rose during these cycles, it would have existed only temporarily, extinguished before it could leave behind architecture or tools. Its only legacy would be patterns, sudden bursts of complexity, abrupt collapses, strange chemical gradients, or fossilized behaviors that diffract from evolutionary expectation. These resets not only erase civilizations but reshape the rules of life itself. After Snowball Earth, life exploded in new directions. After mantle overturns, ecosystems reorganized. After ocean anoxic events, evolution leapt forward with surprising intensity. These rebounds are too rapid to seem purely natural. They resemble recovery guided by underlying mechanisms, perhaps remnants of ancient systems attempting to stabilize the biosphere or restart complexity after collapse. Each reset, then, is not merely an ending. It is an opportunity for emergence. And if we look closely at what survives these catastrophes, we begin to see patterns that resemble resilience strategies. Life clings to deep-sea vents, underground shelters, isolated chemical refuges. These refuges could have supported intelligence in forms we do not recognize: fungal networks, chemical intelligences, colonial superorganisms. When catastrophes came, they would collapse, but fragments of their behavior, structure, or environmental influence might persist, leaving behind the fossil footprints we interpret today as anomalies. To trace these fragments, To uncover the hidden behaviors of prehistoric organisms that suggest intentionality or coordination, we must now turn to a different kind of fossil. Not bones, not shells, but the preserved movements and collective patterns of ancient life. Behaviors frozen in sediment that speak in the quiet language of action, coordination, and complexity, bringing us into the strange realm of behavioral fossils and the possibility that life once acted with purpose long before recognizable forms of intelligence evolved, guiding us toward if Earth's deep resets destroyed every physical trace of prehistoric civilizations, then the story of ancient intelligence must be sought not in the remnants of bodies or structures, but in the patterns of behavior captured in stone. Behavioral fossils are among the most revealing yet overlooked forms of evidence in the geological record. They preserve not what organisms were, but what they did. And in many cases, what they did should not have been possible for life as we understand it at that time. A behavioral fossil is the imprint of an action, a trail, a burrow, a coordinated migration track, a patterned disturbance in sediment. These are the frozen footprints of decisions, responses, strategies. And when behavior surpasses the complexity of the organisms believed to have existed, we are forced to ask whether something more sophisticated, something intelligent, was at work. In some of the oldest sediments, long before the dinosaurs, long before vertebrates even existed, we find trackways that form perfect parallel lines extending over remarkable distances. These are not the random movements of solitary organisms, but the synchronized paths of groups moving together with deliberate precision. Some tracks curve with mathematical consistency, as though following an environmental gradient known to the collective. Others split and rejoin with fluid coordination, much like the branching patterns of modern flocks and schools, but occurring hundreds of millions of years before such complex behavior should have evolved. Even more perplexing are the burrow networks. In layers dated to the Cambrian and earlier, we find sprawling underground labyrinths carved with geometric regularity. These networks maintain uniform spacing, consistent diameters, and symmetrical angles. They resemble engineered tunnel systems rather than the instinctual diggings of simple organisms. The branching patterns correspond to principles seen in modern optimized networks, transport systems, irrigation patterns, even early computer algorithms. Yet these fossils predate brains. They predate centralized nervous systems. So who or what carved them? Some paleontologists argue that these structures could be the result of simple chemical cues guiding collective behavior. But this explanation only shifts the mystery. Chemical communication on this scale implies a distributed intelligence, an awareness shared across a colony or superorganism. To carve tunnels that maintain structural integrity, that avoid collapse, that regulate spacing, requires more than instinct. It requires feedback, adaptation, and problem-solving, traits associated with intelligence, even if expressed differently than in humans. Then there are the so-called feeding traces, where organisms etched spiral or radial patterns into the seafloor. At first glance, these appear decorative, almost ceremonial, but analysis reveals something more. The spirals expand with steady ratios, governed by geometric progression. The radial patterns match optimal foraging algorithms used in modern robotics and computer science. These creatures, whatever they were not wandering aimlessly. They were implementing strategies. They were calculating the most efficient way to consume resources. Another striking category consists of directional drags, long, continuous trenches carved by organisms moving steadily along fixed axes. Some trenches run straight for dozens of meters, maintaining perfect alignment even across changes in terrain. No known organism of that era possessed the physical or neurological sophistication to maintain such directional discipline. The movement looks guided, purposeful, as if following a magnetic cue or responding to environmental markers invisible to human eyes. This kind of behavior is not primitive. It is structured. In certain fossil beds, we find entire landscapes of synchronized behavior, multiple species interacting in coordinated ways. Burrows intersect with trackways in predictable patterns. Feeding traces align with migration paths. The entire seabed becomes a canvas of interwoven actions, forming a tapestry of ecosystem-level coordination. This suggests something profound. Intelligence may not have been centralized in individuals, but distributed across networks of organisms. A civilization not built of cities or tools, but of relationships, patterns, behaviors. This type of intelligence is not alien to Earth. Today, slime molds solve mazes without neurons. Ant colonies build architectural wonders without architects. Fungal networks manage resources across forests with strategic efficiency. Coral reefs behave like superorganisms, responding to environmental changes as unified bodies. These examples demonstrate that intelligence does not require brains. It requires systems. Now project such distributed intelligence into Earth's deep past. Imagine networks more advanced than modern ants, more expansive than fungal webs, more adaptive than coral systems. Over millions of years, such intelligences could engineer ecosystems, optimize environments, shape planetary chemistry, and record information in patterns rather than artifacts. When extinction events came, their bodies would dissolve, but their behaviors, etched into the sediment, would remain as silent fossils. The most haunting behavioral fossils are those that resemble scripts or sequences. In some ancient beds, we find repeated patterns executed with minor variations, as though following coded instructions with slight errors, like versions of a program. These sequences are too consistent to be random and too intricate to be instinctual. They imply memory, decision, refinement. If this represents the work of an ancient civilization, its technology was not mechanical, but behavioral. Its architecture was not stone, but action. All these traces, parallel trackways, geometric burrows, optimized feeding spirals, directional trenches, ecosystem-wide coordination, form a mosaic of intelligence that predates the dinosaurs by hundreds of millions of years. They challenge the linear narrative of evolution. They suggest cycles, rises, collapses. They hint that intelligence may not have emerged once, but many times, in many forms, each time erased by cataclysms, but leaving behind echoes in the fossil record. Yet these behavioral fossils become even more intriguing when viewed alongside cosmic cycles. Many bursts of complex behavior align with periods of increased cosmic radiation, orbital shifts, or comet activity. This correlation suggests that ancient intelligence may have responded to, or even anticipated, cosmic events. And to explore this connection, we must ascend from the sediment into the celestial patterns that shape Earth's rhythms, drawing us into the mysterious realm of cosmic resonance and the possibility that intelligence, evolution, and astronomical cycles are, if the behavioral fossils of ancient life hint at intelligence rising long before the age of dinosaurs, then the cosmos itself may hold the key to understanding why these cycles emerged, intensified, and collapsed with such regularity. For Earth is not an isolated world drifting aimlessly through space. It is immersed in cosmic rhythms, patterns of gravitational pulls, radiation bursts, orbital harmonics, and galactic movements that shape the planet's climate, chemistry, and evolutionary tempo. Life on Earth has never been separate from the universe. It has always been synchronized with it. And if prehistoric civilizations existed, their origin and fate would have been woven directly into these celestial cycles. Begin with orbital harmonics. Earth's orbit is not a perfect circle. It stretches, contracts, tilts, and wobbles in cycles that span tens to hundreds of thousands of years. These cycles, Milankovitch cycles, shape the rhythm of ice ages, sea levels, atmospheric composition, and global temperatures. Modern humans barely perceive these shifts, but life over millions of years must respond dramatically. Ancient intelligence, if it emerged in these deep eras, would not measure time by days or seasons, but by orbital phases. Civilizations may have risen during periods of orbital stability, when climate fostered complexity, only to vanish when orbital shifts plunged the world into chaos. Yet orbital cycles are only the beginning. Earth is continually exposed to cosmic radiation from supernova explosions occurring tens of light years away. These events shower the planet with high-energy particles, altering DNA, affecting cloud formation, and influencing climate. Geological layers from certain prehistoric periods contain spikes in isotopes like iron-60, evidence of nearby supernovae. These same layers often coincide with sudden evolutionary leaps or abrupt extinctions. Cosmic radiation acts as both a destroyer and a catalyst. It tears down ecosystems and seeds genetic innovation. If intelligence existed during these cycles, it may have interpreted the sky's brightening as signal or warning, understanding the connection between celestial brilliance and earthly upheaval. The solar system's path through the galaxy adds yet another layer of cosmic influence. As Earth orbits the Milky Way, it passes through regions of varying density, magnetic fields, and radiation levels. These galactic tides exert gravitational forces that disturb comet reservoirs, sending waves of comets into the inner solar system. Some bring destruction, others bring organic material. The correlation between mass extinctions and galactic position is striking. Every few 100 million years, as the solar system enters more turbulent regions of the galaxy, extinction events spike. If prehistoric civilizations existed, they would have experienced these cycles not as abstract astronomy, but as existential reality. Their rise and fall would have been tied to galactic rhythms. Comets themselves act as cosmic metronomes. Their periodic returns mark transitions in Earth's environmental stability. Their impacts reshape continents. Their dust alters climate. Their presence in the sky has been feared or revered by civilizations across human history. But prehistoric civilizations, those woven into biological networks or ecological systems, may have understood comets differently, not as omens, but as signals, as markers of cosmic timing. Their synchronized behavior, like the mirrored sunward tails of R2 SWAN and 3I Atlas, could represent rhythms embedded in deep time, rhythms guiding environmental cycles that shaped the evolution of ancient intelligence. Some researchers propose that cosmic cycles influence evolutionary detonations. Radiation from supernovae increases mutation rates. Gravitational tides alter global volcanism. Orbital shifts change climate rapidly enough to force adaptation. These pressures accelerate evolution, sometimes producing leaps rather than gradual change. If intelligence emerged during these windows, it would appear suddenly, flourish briefly, and collapse when the cycle shifted again. Each cycle would produce a new iteration of complexity, a new chance for intelligence to rise. The fragmented fossil record may not show gradual development because intelligence may have emerged repeatedly, each time erased by cosmic reset before leaving durable traces. Magnetic field reversals add another cosmic connection. Earth's magnetic field flips irregularly, sometimes weakening for thousands of years. During these windows, cosmic radiation reaches the surface more intensely, influencing evolutionary pathways and environmental stability. Some behavioral fossils align with these periods, as though organisms responded to increased radiation with new behaviors or collective strategies. Prehistoric civilizations may have used magnetic variations as part of their environmental awareness, sensing cosmic cues imperceptible to modern humans. The sun's own cycles influence Earth deeply. Solar minima and maxima dictate cosmic ray levels, atmospheric ionization, and climate pulses. Some ancient organisms appear synchronized with solar rhythms, shifting behaviors or growth patterns in alignment with solar activity. If intelligence existed in these deep eras, it may have measured time not in years, but in solar cycles, modeling its survival strategies around fluctuations in radiation, temperature, and light. Even Earth's position relative to the galactic plane may influence life. Periodically, the solar system drifts above or below the galactic disk, exposing Earth to different cosmic environments. These long cycles, tens of millions of years, correlate with major evolutionary events: the rise of complexity, extinctions, bursts of innovation, collapse. If ancient civilizations existed before the dinosaurs, they may have risen during stable passages of this cycle and fallen when Earth entered harsher cosmic regions. Taken together, cosmic resonance provides a framework for understanding why intelligence might emerge in pulses. The universe sets the tempo. Earth responds. Life adapts. Civilizations rise. Catastrophe resets the stage. And through each cycle, patterns repeat. Patterns now echoed in the synchronized behavior of R2 SWAN and 3I Atlas. Their mirrored sunward tails may reflect forces larger than human comprehension, forces that ancient intelligence once recognized intuitively. To explore how this ancient knowledge might have survived, not in fossils or artifacts, but in stories, symbols, and dreams passed down across unimaginable spans of time, We must now turn to the realm where memory outlasts extinction. Mythology, encoded across human cultures like fragmented echoes of eras older than history, guiding us into the possibility that myth is myth, has always been treated as metaphor. As symbolic storytelling. As a human attempt to explain a world once mysterious and terrifying. Yet when we examine ancient myths through the lens of deep time, through the possibility that intelligence may have risen and fallen long before the dinosaurs, the stories take on a different character. What if myth is not metaphor? What if myth is memory? Not personal memory, not cultural memory, but biological memory inherited across millions of years. Echoes of experiences lived by organisms, networks, or civilizations so ancient that their physical traces have been erased, but their emotional and symbolic imprints remain embedded in the subconscious architecture of life. Across the world, cultures separated by oceans and millennia tell the same stories. Floods that reset the world, serpents descending from the sky, ages of creation and destruction that repeat in cycles, beings of light who shape the world and vanish, worlds that end not once but many times. These mythic motifs appear in Sumerian texts, Mayan codices, Hindu cosmology, Aboriginal dreamtime, Norse epics, African oral traditions, and Native American legends. The details differ, but the structure remains astonishingly consistent. How did stories so similar arise from civilizations that never contacted one another? One explanation is psychological universality. Another is convergent storytelling shaped by natural catastrophe. But a third, far more provocative possibility is that these stories are inherited, passed down through genetic or subconscious pathways from vastly older epochs. If intelligence existed before the dinosaurs, its collapse would imprint trauma on ecosystems, on biological networks, on the evolutionary lineages that survived the reset. Those lineages, microbial, fungal, oceanic, could carry the emotional memory of catastrophe forward. When humans later evolved consciousness, those ancient imprints might surface in dreams, visions, and myths, translated into symbols familiar to the human mind. Take the global flood myth. Nearly every culture preserves it, yet the timing of prehistoric floods does not align with human memory, but with much older events, massive anoxic episodes, rapid ice melts, oceanic overturns. These events devastated entire biospheres long before mammals evolved. For organisms that lived through such catastrophes, the memory of overwhelming water, suffocating darkness, and environmental collapse would be encoded not in story, but in survival instincts. Humans later reinterpreted those primal feelings as narratives of deluge and rebirth. Sky serpents appear just as consistently. They are emblazoned in Mesoamerican pyramids, painted in Aboriginal caves, carved on Norse stones, woven into Chinese myth. Always serpents. Always celestial. Always guardians or destroyers. Why serpents? Because comets, with their twisting luminous tails, resemble writhing forms in the sky. A civilization existing millions of millennia ago, whether networked in oceans or spread through early ecosystems, might have experienced comet-driven environmental shifts so profound that the sight of a luminous tail in the sky became associated with existential threat. That emotional memory may have survived extinction, re-emerging in human myth as sky serpents signaling the beginning or end of ages. Cycles of creation and destruction form another universal pattern. Hindu texts describe yugas, repeating ages that rise and collapse. Mayan inscriptions speak of suns that end and begin. Greek mythology tells of ages of humanity destroyed and reborn. These cycles mirror Earth's catastrophic resets: snowball Earth, mantle overturns, volcanic floods, events far too ancient for human society to remember, yet embedded in mythic timelines as if recalling epochs absent from human history. Perhaps because life itself remembers. Perhaps because consciousness inherited rhythms older than our species. Even beings of light, angels, deities, luminous ancestors, may reflect ancient experiences of cosmic radiation, supernovae brightening the sky, solar storms filling the atmosphere with shimmering auroras, gamma ray bursts altering life in ways organisms could not understand. The emotional imprint of overwhelming brightness, awe, and fear could survive in the collective subconscious, resurfacing as stories of divine beings arriving in times of crisis. Another category of myth reveals memories not of cataclysm, but of guidance. Many cultures describe early beings who taught agriculture, astronomy, healing, and survival. These civilizing figures often come from the sea, the sky, or deep places of the earth. They appear briefly, transform the world, and vanish. Such stories may symbolize not external visitors, but the resurfacing of ancient knowledge encoded in the subconscious, hints of past civilizations whose influence survives not in tools, but in instinct. Humans might have tapped into these latent structures during moments of extreme need, translating them into mythic teachers. Dreams strengthen this possibility. Humans often dream of floods, falling skies, cosmic light, endless darkness, and vast oceanic worlds. These themes appear regardless of culture, geography, or upbringing. They resemble instinct more than memory. Some neuroscientists argue that dreams compress evolutionary experience. If this is true, then dreams may be the medium through which ancient intelligence still whispers. Dreams as messages, dreams as archives. Dreams as the final remnants of civilizations wiped clean by Earth's cycles. Symbols in early human art reinforce this idea. The same geometric patterns appear in Paleolithic caves across continents, spirals, grids, radiating lines. These shapes match natural patterns found in ancient organisms, trilobite eyes, stromatolite layers, Ediacaran fractals. Human creativity may have been influenced by subconscious recognition of shapes embedded deep in evolutionary memory. These patterns may not be inventions but recollections, a biological inheritance from worlds long destroyed. The universality of myth, dream, and symbol suggests that human consciousness carries fragments of stories far older than humanity. Stories from worlds erased by geological amnesia. Stories from civilizations whose bodies and structures dissolved, but whose experiences lingered in the evolutionary substrate. And if myth is memory, distorted, symbolic, encrypted, then consciousness itself may be the last surviving archive of civilizations that lived and died before the dinosaurs. To understand how consciousness preserves these echoes, how a mind shaped by millions of years carries imprints of epochs it never lived, we must step into the final layer of this investigation, exploring the possibility that consciousness is finally, when all physical traces have vanished, when continents have drifted and subducted, when oceans have boiled and frozen, when comets have swept across the sky and eras have folded into oblivion, something remains. Not in stone, not in fossil, not in artifact, but in awareness. Consciousness becomes the last vault, the final archive, the only medium capable of carrying echoes of worlds erased by Earth's cycles. If civilizations existed before the dinosaurs, their memory does not lie buried beneath layers of sediment. It lies within the architecture of perception itself, woven into instincts, dreams, symbols, and the quiet intuitions that shape human thought. Consciousness did not appear suddenly with humanity. It is the culmination of millions of years of evolutionary refinement, an inheritance shaped by organisms that learned, adapted, coordinated, and survived. If ancient civilizations existed as biological networks or ecological intelligences, then their successes and failures would be etched into the behavior of the organisms that endured catastrophe. Those organisms became ancestors to later forms, carrying encoded impressions forward. Over time, these impressions accumulated, forming layers of subconscious memory that modern humans inherited. In this sense, consciousness is the fossil of experience rather than anatomy. Instinct offers the first clue. Humans instinctively fear darkness, deep water, falling skies, sudden silence, and shifting light. These fears do not come from personal experience. They come from ancestral experiences repeated across epochs, experiences that may include catastrophes far predating mammals. Some instincts align perfectly with events known to have shaped life millions of years ago: suffocation during oceanic anoxic events, freezing during snowball Earth, scorching during volcanic winters, fleeing before cosmic impacts whose brightness turned night into day. These experiences would have traumatized entire ecosystems, imprinting themselves upon the biological lineage that survived. Humans today still carry that lineage. Dreams reveal even deeper layers. The human mind travels through landscapes it has never seen. Endless oceans, glowing skies, spirals of light, fractal forests, labyrinths, and ancient beings. These images appear consistently across cultures, across ages, across individuals who share nothing but their biology. Modern neuroscience sees dreams as emotional processing, but dreams may also be windows into the evolutionary subconscious. Fragments of memory inherited not through culture but through biology. If consciousness contains echoes from prehistoric civilizations, dreams are the shadows cast by those echoes. Symbols act as another form of inherited memory. Across early human art, spirals, radiating lines, branching networks, and geometric grids appear with astonishing universality. These shapes mirror patterns found in some of the oldest organisms: the segmented vision of trilobites, the fractal design of Ediacaran life, the branching tunnels of ancient behavioral fossils. Humans may be drawn to these forms not because they are aesthetically pleasing, but because they resonate with recognition, patterns embedded in the nervous system long before Homo sapiens existed. Consciousness sees these shapes and remembers something ancient, even if the intellect cannot explain why. The phenomenon of collective intuition strengthens this idea. Entire cultures develop myths, rituals, and cosmologies that mirror the same cycles found in geology and astronomy. World ages that rise and fall, floods that reset humanity, serpents in the sky, beings of light. Each of these themes matches cosmic or geological phenomena that shaped Earth long before humans emerged. These stories may represent inherited memory of prehistoric cataclysms, preserved in consciousness like faint ripples surviving after the stone has sunk. If consciousness preserves echoes of ancient intelligence, then intelligence itself becomes cyclical. Civilizations rise not from random mutation, but from the reactivation of dormant patterns already embedded within the evolutionary blueprint. It is as if the universe stores knowledge not in monuments or machines, but in the fabric of awareness. Each time life reaches a certain threshold, consciousness reawakens memories buried in instinct and dream, guiding species toward complexity. Intelligence becomes less an invention and more a remembering. This perspective transforms the synchronized behavior of comets like R2 SWAN and 3I Atlas into something more symbolic. Their mirrored sunward tails, drifting together within Earth's outer corridor, may represent cosmic rhythms that once shaped ancient intelligence and may shape consciousness again. Civilizations predating dinosaurs would have understood the sky differently, not through telescopes, but through instinct. Cosmic cycles would not be abstract. They would be embedded in perception, guiding biological behavior, and synchronizing planetary life. If consciousness is the final archive, then human awareness today carries the last surviving traces of world ages erased by fire, ice, water, and cosmic radiation. These traces influence intuition, dreams, creativity, and myth, forming a quiet inheritance that connects us to epochs beyond imagination. We are not merely descendants of apes. We are the living continuation of life that survived ancient catastrophes, remembering fragments of civilizations that vanished before dinosaurs took their first breath. And if this journey into deep time stirred something in you, if it awakened curiosity, recognition, or a sense of belonging to a story far older than humanity, share this video and subscribe. Your voice is part of this unfolding exploration. Your presence ensures that these forgotten epochs are not lost again. For in the end, the greatest mystery is not what came before us, but why fragments of those forgotten ages still echo within us. If consciousness truly carries the memories of worlds erased by geological amnesia, then the story of prehistoric civilizations is not finished. It is waiting. It is alive. It is woven into every instinct, every dream, every question that emerges when you look at the night sky and feel, without knowing why, that we have been here before.